Okay, today class we're starting Unit 1, Atomic Theory. Our objectives for this lecture are to talk about the atom in terms of the particles that make up the atom. We're also going to learn how to write atomic symbols of atoms and their isotopes and ions, and make sure we know how to count number of protons, neutrons, and electrons. First, we're going to talk about the atom as we know it today. We know that it's an electrically neutral, spherical entity made up of a positively charged nucleus surrounded by negatively charged electrons. The nucleus has both protons, which are positively charged, and neutrons, which have no charge. Okay, and if you look in this picture, you can see the comparison of size between the nucleus and what we call the electron cloud, where the electrons are. You can see the nucleus in the middle is very tiny compared to this huge cloud around it with the electrons in it. Okay, and just for you to understand, also let me explain something else before I move on. You can see that when you pull out the nucleus to look at it right here, you can see that it is made of both protons, which are positively charged, and neutrons, which have no charge. Okay, and I want you to look at the symbols we're going to be using for proton, neutron, and electron. Proton, we're using a little p with a plus. Neutron, we use a little n with a 0 for no charge. And electron, we use a little e with a negative sign. Okay, so just get used to those symbols because we're going to be using them quite a bit. So anyway, this chart is very important for you to understand the characteristics of these subatomic particles. Just to reiterate, the atom is made up of the proton, neutron, electron. You've got to know that both the proton and the neutron, are located inside the nucleus, and the relative charge is 1 for the proton and 0 for the neutron. If you look at the mass of the proton and neutron, now this is a relative mass. That means comparing it to the mass of the electron as well. You can see that the bulk of the weight is in the nucleus. That's where the mass of the atom is. And you can see as far as the electron, which is located outside the nucleus, you can see that the weight of the electron is negligible compared to the rest of the atom, which would be the proton and the neutron. So this is an important chart to know. So make sure you pause this and write this down in your notes. Okay, now that we know the general structure of the atom, we're going to learn to write atomic symbols. Okay? And it's just a way of writing and being able to know about the atom, or what's called an isotope. So let me first talk about an atom and the way we're going to write the symbol. If you look up here in the top right corner, this is how we write the atomic symbol of an element or an atom. The X in the big X stands for the atomic symbol of the element. So for example, C is for carbon. Okay? And if you're not familiar with the atomic symbols, your yellow periodic table has all the symbols along with the names with them. On the left top is where you're going to put something called the mass number. Okay? And we use the letter A to represent the mass number. And the mass number, remember the mass of the atom is in the nucleus. That's where the big belly is, the nucleus. Okay, so the mass is equal to the protons plus the neutrons. Remember, the electrons really don't add any weight to the atom. So that's the mass number, how much that atom weighs. Okay. Then below it, you have something called the atomic number. Okay, and that's one of the most important numbers That number tells you what element you're talking about. And that number is the same as the number of protons in the nucleus. Okay, so if you know the number of protons in the nucleus, you know what element we're talking about. And we use the letter Z to represent the atomic number. Okay, so just to reiterate, you have the atomic symbol. Okay, and we're looking at this little picture here. We have the mass number, which is the protons plus the neutrons, and we have the atomic number, which is the protons. So for now, you might have to write that on your paper and look at that when you're writing atomic symbols. Okay. Now, we can also use these numbers to figure out the number of neutrons in the nucleus, and we'll show you that in a minute when we practice. Okay. But let's first talk about an important definition that you should know and get in your notes, which is an isotope. An isotope is an atom of the same element with the same number of protons but a different number of neutrons. So remember, the protons is what tells you what element it is. But if you have a different number of neutrons, which gives it a different weight, it's still the same element, but it's an isotope of that element. So if you look here at this picture on the right that I'm circling, you'll see two atoms of uranium. One we're calling uranium-235, and one that's uranium-238. They are both the same element, but they are isotopes of each other. Meaning, if you look at the nucleus, they have the same number of protons, meaning they're the same element, but they have a different number of neutrons. These are isotopes of each other. Okay? So the mass number can change. The mass number is just showing you one isotope of the element. Okay, and sometimes there's only one isotope. Sometimes there's several. Okay, now let's look at your periodic table. I want to show you an example. I'm going to draw on the next slide, but I want to make sure you understand how to relate what's on your periodic table to what the atomic symbol. Okay, so let's take something like nitrogen, for example. Or actually, let's take carbon. Okay, so if you look at your periodic table, and if you need to pause this to get out your periodic table, let's take carbon. I'm going to just draw a box from the periodic table. So I'm going to put PT for periodic table. And this is what you should see for carbon in your periodic table. There should be a C, have the name carbon under it. Then there's a number up top, which is 6. And then there's a number on the bottom, which says 12.01. Okay? Now, let's say the reason there's a decimal here is because this is the average atomic mass. That's the average of all the isotopes of carbon, not just one. So this is the mass, the average mass of all the isotopes. We're going to do that in another day, but this is the average atomic mass of all the isotopes of carbon. Now, if we wanted to write the symbol for one isotope, and I'm going to pick one. I know what all the isotopes are. You may not at this point, but I'm going to write carbon 12. Okay, and that's how this number here shows the mass number of that isotope. Okay, so this right here is the mass number A, mass number of the isotope. So if I'm going to write the symbol, remember our format, okay? This is the format for the symbols is you write the element, you write the mass number on top, and the atomic number below it. Okay, that's our little format that we just learned. So if I was going to write the atomic symbol for carbon, in the middle, the big number would be, or excuse me, the big letter would be carbon. And then as far as the mass number, okay, I'm going to use the 12. This is one isotope of carbon. Note that I'm not using the 12.01. This is one isotope. And then on the bottom, of course, it's going to be the atomic number. So this right here on your periodic table is the atomic number Z. So that 6 goes right there. So you can see that you can get the atomic number right from the periodic table. And I know it's confusing that you put it on the bottom and it comes on the top in the periodic table, but it's just the way it is, and you just got to get used to it. Okay? So just to reiterate too, you're never going to get the mass number from the periodic table, only the atomic number, because the mass numbers of all the isotopes. And for a symbol, we just want one isotope. Okay? So let's do some examples together to make sure you understand how to do this. Okay? So the first name they're giving you is hydrogen 1. Okay, and the first thing they want you to do is write the nuclear symbol. And you can see they give you some things. You have the atomic number here. You have the mass number, which is A. You have the protons, neutrons, and electrons. Okay, so in some of them, they're filling in some of the information. Okay, hydrogen 1. Remember this 1 right here? That's going to be the mass number of this isotope. So that is telling you the protons plus the neutrons. Okay, remember the mass is both those things added together. Okay, so if we're going to start, let's just start writing the symbol first. We know that the H goes to the right. The top left is the mass number, which they give us as 1, right? That's right there. Okay, and then the atomic number we can find on our yellow periodic table, which is 1. So that's going to go there. Okay, so we filled in the nuclear symbol. Now we're going to do the mass number, which we already said was 1. Okay, the protons we know is 1 because it's the same as the atomic number. These two numbers are the same. Now the protons we're going to get, remember the mass equals the protons plus the neutrons. So if we know the mass is 1 and we know the protons is 1, that means they have no neutrons. We do a little simple math there to get the neutrons. The mass number minus the protons will give you the neutrons, which is a big old 0. Okay, now let's talk about electrons for a minute. Atom is neutral. Okay, so when you see the word atom, think of it as neutral. That means the positive is going to equal the negative. Okay, so if there's one proton, there's going to be one electron to negate it and make it a neutral atom. Okay, so for neutral atoms, the protons will equal the electrons. Okay, so for a neutral atom, the protons will equal the electrons, because those are the only two subatomic particles that have any effect on the charge of the atom, because remember, a neutron is already neutral. Okay, so the protons will equal the electrons for a neutral atom. All right, let's go to the next example, example 2 here, right here. Okay, so now they don't give us the name, they give us the symbol. So now we have an N. So if you don't know what N is, you have to look it up and you find that it's nitrogen. Okay, so remember I got a book on, so my writing is terrible. Okay, so nitrogen. Now what you put after it is you got to show what isotope of nitrogen it is, and you put the mass number, which is the top number. So it's nitrogen 15. Okay, the atomic number is the bottom number, and you can actually even confirm that on your periodic table. That would be the top number on your periodic table, but the bottom number in the symbol, which is 7. Okay, the mass number we already said was 15. The protons equal the atomic number, which is 7. They gave you the neutrons, so remember the protons plus the neutrons right here will equal the mass number, which it does. And then again, electrons will equal the protons for a neutral atom. So that's also 7. Okay. Now next, we have aluminum 27. Okay, I'm going to erase some of this. You can always go back and take notes if you need to, just so I have some more room. Aluminum 27, our symbol for aluminum is Al. Mass number is 27, that goes on the top. We have to look up the atomic number. When you look it up for aluminum, you can see that it's 13. So then again, once again, our atomic number, which you can get from the periodic table, is 13. Mass number 27. Protons is the same as the atomic number, which is 13. Neutrons, remember, protons plus neutrons gives you that weight, which is the mass number. That means 13 plus the neutrons is going to be 27. Do a little simple math, you find that the neutrons will be 14. 13 plus 14 is 27. And then because it's a neutral atom, you have 13 electrons. Okay, so that's an example for neutral. Okay. Now we need to talk about ions. Okay, and what is an ion? Okay, so what I'm going to do is these are important definitions that you need to have in your notes. Okay, when we talk about an atom, we think neutral. That means no charge. Protons equal the electrons. There's another word called ion. Okay, and it's not neutral. Okay, so an ion is not neutral. Okay, and what you can call it is, it's really like a charged atom, an atom with a charge. Now, there's two words for ions. Okay, if it's a positively charged ion, okay, so if it's positive, we call it a cation. I always remember it that cats are so positive. They make our lives better, even though I hate cats. But that's how I remember cation is positive. If it's negative, it's called an anion. Okay, and you can remember negative, and got that N in there. Okay, so there's two words for ions. A cation is a positively charged ion, an anion is a negatively charged, but an ion is just a charged atom. Okay, and when you have an atom, the only thing that's going to change is the electrons. The protons don't change. Okay, so the only thing that's going to change when you have an anion or a cation is that you either gain or lose electrons. Okay, so let's go back to now, examples with charges. Okay, now here's how you write them. Look at the first one. Okay, and we're first going to just look at magnesium. Just drag this over. Okay, magnesium 24. So again, still that's magnesium 24. That's the mass number. And then notice they wrote cation 2+. So this atom has a positive charge of 2. Okay. So the first thing I'm going to do before I go into how to write the symbol and everything and count the protons, neutrons, electrons is I'm going to draw a little picture for you to show you what the electrons would have to be to make that positive 2 charge. Okay, so that's what I want to do. I just want to show you. Because what I'm going to show you is that if it's a +2, a net +2 on that ion, that means it lost 2 electrons. Okay, and that's what people get confused about. So let's draw first a neutral magnesium 24. So if you look at magnesium on the you'll see it has 12 protons. Okay, so first I'm going to make my nucleus a little bigger just so I can fit the 12 protons in. Now if you look at it, it's atomic number 12. We have 12 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Now, if it's neutral, so this is my neutral one, okay, so this is my atom. That means it's got 12 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Protons equal the electrons to cancel it out. Now, if it's an ion, that's +2. Let's think about it. Okay, let's draw this again. Now, remember, the protons can never change. You change those protons, you change the element, and we can't change the element. So we still have 12 protons in here in the nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 protons. Okay, so if we want a +2 charge, how many electrons do we have to have? Okay, you can even do it as a little algebra problem, right? You've got +12 plus x equals +2. And if you solve for x, it's got to be 10. You have to have 10 electrons. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what you see here is that if it's a positive charge, you've lost 2 electrons. Okay, so you got to get that in your head that when you have a positive charge, you're losing electrons. When you have a negative charge, you're gaining electrons. So if we had to do this problem and we write the symbol, so let's first write the atomic symbol and then we'll count the protons, neutrons, and electrons. Protons, neutrons, and electrons. Count one. Okay? So let's write the symbol. So that's magnesium, the symbol. Mass number is on top. Atomic number is on the bottom. Numbers changed from the neutral atom. Notice that. Okay? But the way we write the symbol now is you have to put the charge over here. Okay? So that's the only difference writing an ion for the symbol. Okay, and now, how many protons? Protons can't change, okay? So there's still 12. Neutrons, remember, it's going to be the mass number minus the protons, so that's also 12. Now, the thing that's going to change is the electrons. Okay, the electrons are going to change. So you lose 2 electrons to make it a +2, so the answer is 10. So this is the only number that's going to change between an atom and an ion. Okay, so let's do one more example with an anion. Okay, so let's get rid of this, and we're going to do this one. Okay, antimony 125. Now, this might be a hard one to find on your periodic table, but it is SC. Okay. Number 1 on the name is SC, comes from a Latin name. Okay, so the mass number is 125. The atomic number is 1. This is what I get from my periodic table, guys. And then I just write that 3 negative here, or -3. Either one is fine. Okay. Now, let's count our protons, neutrons, and electrons here. Okay, remember, the only thing that's going to change is those electrons. So the protons, 51. Neutrons will be the mass number minus the protons, which is going to be 74. And the electrons, now we've got a -3. So that means we're gaining 3 electrons, which means our electrons are 54. Okay, and so those are our examples of how to do atomic symbols with atoms and ions. Make sure you know the definition between an atom and an ion, an isotope. You can review this video. Thanks, and we will do problems in class.